Yo, what's up, everybody? Welcome back. Today, I want to poke around and see if I can understand how these like Raspberry Pi Pico boards work at a pretty low level. I've got one of these guys here, and I just want to see like what the fuck does this thing do? Right? So context is that I have this like Xbox controller kind of right. I've got this guy, and on the back of him, he's got a couple paddles, right? So these guys are like extra buttons. But the firmware of this controller only allows me to remap those paddles to other buttons on the controller, right? So from the perspective of my PC, I'm only seeing like it doesn't know that the paddles exist. And that kind of pisses me off because my computer has like a lot of buttons on it and it could handle a lot more buttons than like the like 10 that a normal controller supports, right? And it would be nice if I could use those paddles to do something like bind them to the push to talk key in a game or on Discord or something, right? Right now I can't do that without sacrificing a button from the game, and that fucking sucks. And so I've been like kind of on this like saga for a little bit. I installed this like Windows virtual machine so I could download the software for this controller so that I could like get the firmware image from an upgrade. And then I like, try to like bin walk that thing, and it doesn't look like there's anything really like interesting in there. It looks like a jumble of bytes. I try like decompiling it for a few like guesses of CPUs. I don't really see anything that like resembles like real disassembly in there, so that is kind of like a dead end for now. There's more I could do there. I could try like reverse engineering their firmware uploader and stuff, but I don't think that would really give me the results I'm looking for. So then I'm like, okay, let's pop open the controller and see if we can like glean any info about this thing, right? So I believe this is like the big brain of this guy, BP1U845, right? The USB port is kind of like here, right? So it would kind of make sense that this guy's connected to USB. He's got like a lot of traces coming off him and a lot of pins, right? So the expectation here is that probably this guy's like doing all of the hard work, right? Yo, top secret late night stream, super late night stream for you. Aren't you usually like deep asleep by now, Mlug? And so, I Google this chip and this gives me like nothing at all, nothing interesting at all, right? If you just type that thing into Google, BP1U 845, it's literally nothing. Which is shocking to me, right? So I don't know like what's going on there. That's kind of weird. But it is what it is. And then I found this chip though. This chip has something interesting on it. This is a flash chip. It looks like AT24, what does that say? AT24C64. And this is 2-wire serial EEPROM. And so I'm like, okay, I have like no leads right now. So I guess we try to desolder this thing. We try to like take this thing off the board and like dump the flash. That's kind of like my current idea. And I'm like, how the fuck do you dump flash? I don't fucking know, man. And so I start Googling around, and it seems like what people do is they buy a microcontroller that has the right interface, right? So I want something that has I2C on it, because this thing, where does it say that I2C? Well, if you look up the pin names, SDA and STL, this is I2C. Right, so we need something that can like interface with a chip that does I2C and use that to like talk to this guy, wherever the fuck he was, this guy, and try to like extract the tasty data on there. Who knows what's on there, right? I'm assuming that this is going to be like the firmware image that this thing is booting off of, but I could be totally like fucking wrong there, and this could be only used for like configuration data, in which case it won't really have anything too useful for me. But it's my only lead right now, right? So we might as well explore it and see what happens. And so I bought this. I went to DigiKey. Let me make sure this doesn't like leak my fucking address. I don't think so. And I just like started like from working at places before that made stuff. I know that they bought stuff from DigiKey, and so I just like punched this thing in here. AT24C64, and you can just buy these things, right? So they have 18,000 of them in stock. It was 18,364 the other day. I bought two. I bought two, and I bought like a pad to put it into a breadboard, and then I just like was like, well, how the fuck What the fuck do I do here? So I just punch in like microcontroller, right? Or and I'm like, surely like something in here. It wasn't any of these actually. Embedded MCU evaluation boards. Maybe it was this. And I just like sorted by like how many of them they have. Right? So I'm like, surely if they have a lot of these things, they're probably pretty popular. And we come into the Raspberry Pi Pico, right? Which is, I'm paying like 750 Canadian for this thing. Probably getting scammed a little bit. These things probably only cost like a couple dollars to make or whatever, and I'm probably paying a lot for the brand name of Raspberry Pi. But like $7, fuck it. Fuck it, right? So I have one of these things now. It's sitting on my desk. On this thing does have an I2C interface. There's little blue pins. In fact, it's got many of them. It looks like. Why the fuck? What am I looking at? So it's got two I2C controllers, I guess, that map to many different sets of pins. I guess so you can choose which one of these are most convenient, so you're not like duplicating other functionality and stuff. This is gonna be fun. Do you have a 2-camera setup? I wish. I wish. But I don't right now. But it's okay. I also have to clean my desk, dude. It's fucking disgusting. But we'll get there. So, today's plan is to just try to understand how this thing works. I've been reading. I was like playing with it a little bit, like earlier today. This is why I'm streaming at 5 o'clock instead of 12:30 like normal. Is because I didn't think that it was going to be anything interesting. But I like downloaded the SDK for this thing and started like building examples, and I was starting to poke around to see like what if I didn't want to use the SDK, like what does that look like? Um, and that's where it started to get like a little bit more significantly interesting. So I figure it's worth streaming. Let's try to see if we can like compile something with no SDK. Maybe see if we can get like a little blinky LED example from Zigland. That'd be kind of cool. But really, I'm just trying to understand like how the fuck does this thing work? Kind of like at all. And so yeah, plan is to start with like the official, the official world that they have, and then I'll work our way backwards into like a more and more stripped down example and see how far we can get. Okay. So step one, if you look up like Pico Raspberry Pi Pico examples, there's a nice little repo here for us. So let's start here. Make der Pico. Make der Pico. All right. And then if we go in here and we just like, I guess we could skim the README a little bit. I know that it uses CMake already. I already found this out earlier. So, we'll just assume that that's the right answer. CMake up a level, and I guess this should be a little bigger, huh? And I guess we need a CMake, I guess. I guess let's kind of start making like a little shell next, because I'm gonna forget what we need. Mix packages. It's like with, and then you do this. Make shell question mark with like native build inputs. I think this is how you do it. We'll see. It'll bitch at me if I'm wrong. Boom, 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 boom. All right. CMake dot dot. He's mad because we need the Pico SDK path, so I think you just need to do like Raspberry Pi Pico SDK. Let's get that bad boy. This thing, I guess. Clone. Well, give him a sec. And then we go build again. CMake Pico SDK path is up 2 directories. Pico SDK. Hype. Pico toolchain path. So they want this thing, which Nix can give to us. They need a compiler. That's fair. That's fair of them to say. We're like, if you want to compile the code, we need to be able to compile the code. It's like, fine. If you're gonna fucking be like that, fine. 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 CMake. We're getting closer. Python 3. Fine. Gee, it's so picky. Need to compile. That's what I'm saying, dude. He's gotta chill the fuck out. He's gotta chill out. This guy. I think that we don't need much more than this. I think this is most of it. Okay. He is like, yo, I need Pico tool. Skipping hello USB because tiny USB submodule is not initialized in the SDK. Get submodule update init recursive. Pipe. Pipe. And then I think I also saw earlier that they need like another USB library for some of the USB stuff. I think we'll see. Dude, embed TLS, you're killing me. Are we good yet? Almost. Tiny USB. So, I believe that this SDK is giving us like a lot of shit, dude. Like, like this is telling us that they're doing like they have like HTTPS support. Probably is my guess there. This is telling me that they have like, you know, I've run into Tiny USB before when I was looking into implementing USB support in like that operating system we wrote a long time back. So I think this is kind of their C library that they use to do all of the like USB packet handling stuff, and then they just like kind of hook that up to the actual USB hardware to do whatever USB hardware does. I don't really remember. It's been a while. Okay. So now if we CMake, does this thing look a little bit more reasonable? Yeah, so I think that it's not complaining about tiny USBs. Oh, what's this? Module update init recursive here. No? All right, fuck it, whatever. And let's build like the little blinky light example. Maybe make J9. This is gonna take a while, I think. And we'll see where this takes us. I think that while we're here, also, I kind of want to explicitly download Pico tool. This is like their kind of like interact with this bad boy, flash the firmware images and stuff to the board. So while that's happening, we can kind of get on this guy because I suspect that this thing might be building Pico tool with like specific parameters. So let's do the same shit over here. Okay, so we have a little blinky boy, right? We have all of these files. We have some ELF file. We have a UF2 firmware image. And so we have to figure out how to like put this thing on there, which I believe is where Mr. Pico tool comes in. So if we're just like CMake ... and he's gonna say we want the same like Pico SDK path is ... // Pico SDK. So yeah, this is what I saw before. Could not find libUSB, so we can't do USB things, which is a pain in the ass because that's like exactly the only reason that we have this is because we want to do USB things, right? We want to upload firmware to the fucking board, right? So I guess here we're like libUSB, and is that the right name? It might be libUSB1. Yeah, it is. Yeah, libUSB1. Bum. All right, give it a sec, and let's try again. Build CMake ... Okay, now he's not screaming at us. He found libUSB. That's good. And if we build this, is he chilling? Oh, interesting. I wonder if the TLS stuff was for USB. If you're like uploading like an encrypted firmware package over USB or something, that could be why that's there. If it's not. It's interesting to me that the firmware upload tool needs SSL stuff. That's weird. What's boy doing? Oh, there we go. He's chilling now. Oh, geez. Exit. Okay. So now we should have Pico tool here. Hell yeah. And then if I think I remember doing like pico tool help info. And in here, you can if the current program that is on the MCU or whatever the fuck it's called, microcontroller, if it is listening for specific USB packets to reset itself, you can call this with like dash F. Oh, fuck. Oh, that's fucking annoying. Oh, I'm on the wrong fucking account. That's even more annoying. Why am I on that account? Oh, I did all of this from the fucking other... Oh, that's so annoying. I did all of this from my other account. That's so annoying. Okay, we reset. We have to do this again. But we know the right answer now. Okay. So, jeez. Okay, hold on. This is all because I tried to copy paste that image from my other account. I don't think Pico has Wi-Fi, so you're probably right about TLS for encrypted firmware or something. That makes sense. All right. Fuck, that's annoying. Sorry, guys, we have to go through that process again, but it should be faster this time. It should be faster. So we know that we want this repo. We know that we want this repo. And we know that we wanted Pico SDK. And then before we get crazy, let's make sure that we're in the right groups so that we have plug dev. Nice, okay. And then let's go back. So what was in our shell.nix? With import nix packages. God damn it. Packages make shell native build inputs equals with packages. And then it was CMake. I remember Python 3. It was like ARM, GCC ARM embedded or something. ARM non-EABI GCC? Yeah, GCC ARM embedded. And was there something else? libUSB1. All right. Oopies. We're at Embedded Systems course. I need fundamentals. I don't really know what I'm doing. So, I don't know. I picked up everything about embedded that I know because I worked at a company that did embedded. So, I don't know where you're supposed to get that info. But maybe here. Maybe we'll find the fundamentals. We need a pico SDK path. All right. Pico SDK? Nice. All right, we'll try again. Don't forget the submodules. Good call, good call. Recursive. I can't type that word. But I mean, in reality, when you're like, where do I learn stuff? I mean, my answer to this is always like, just do something, right? And like, I know that like that's not the right answer for everybody, but for me, I need to solidify knowledge. I really have to do the wrong thing, is what I find. So I like really internalize knowledge from making mistakes, but I don't internalize knowledge from like reading stuff or like getting stuff right. And so for me, it's always like, let's just like try something, fuck it up as much as you can, and then hopefully at the end of that, you'll have like a little bit of an idea of what the fuck's going on. That's my approach. Everyone's approach is different. So the other thing is when you're like, where do I learn blank? It's like, eventually you'll have to understand, you'll have to learn how to approach problems in the way that is like successful for you, right? So for me, that's like, I just bought this and I'm like plugged it in and we'll try to see what happens. But for you, it might be watch a YouTube video, right? Who knows? Who knows? All right. So are we chilling now? Pico tool, what was it? Info Like this. Nice. Here we go, baby. Let's go. Okay, so we have a guy that can talk to this thing that's plugged into my computer, and it can tell us things about it like, hey, I am a RP2040, which is hype because we actually have the RP2040 datasheet up here, which we're going to be looking at in a second. Okay, so now we have a thing that can do USB communication with our guy. We need to rebuild the Blink example again, but that should be pretty straightforward this time. We just give him a sec. Make -9 Blink. Okay. And hopefully this is quick. I don't really see why it wouldn't be. Oh, I guess he's got like a bunch of dependencies to make. This was the one that took a while last time. Come on, baby. We can watch top and make it feel like we're doing a little better. There we go. Oh, okay. Hype. So I think most of that was dependency stuff. I think that big burst at the end was the actual Blink example. Okay, can we try to like upload this thing? So if we do like pico tool help, work pico tool, build pico tool help. We see on here one of the things that it can do is load stuff. So if we're like help load, we can probably just guess, right? Probably the file. So if we like pico tool load, it was -x file name. So what's in here? Blink UF2. Is that it? Probably. And okay, let's see if my USB cable is like comically short. But bro's blinking. You can see him blinking. Let's go, baby. So that is step 1. We've done everything. We're done. We know how to use it, right? But blind speedrun. I mean, I'm kind of cheating because Blink speedrun. I'm kind of cheating because I did this part earlier today. But this is getting close to kind of where my investigation ended. Okay, so this thing is probably building blink.c, right? And this guy's not doing a lot, right? He's like main, pico led init. I assume like crashes the fucking thing if it's not pico okay. And then he sets the LED with some LED delay. So set LED is calling GPIO put on an LED pin. Okay. And LED init is calling GPIO init, and he sets the direction of the LED pin to out. Okay, so that's interesting. So that means this like onboard LED is controlled as like a GPIO. So I guess the first thing I want to do is like find that on the schematic. Right? So what is it would be nice if we had Clang tools in here so I could jump to definition on stuff. Because I want to like go kind of start poking around the SDK and try to like understand what these things are doing. And so this is the data sheet, right? So can we look for like LED? GPIOs? Maybe IOs. Here. Okay, so here we see that we have like GPIO 0 all the way through 15, blah, blah, blah. Are these like, is this like for the external board? What am I like looking at here? IO headers. So this is probably like the left and right side of the board, right? This is probably this. So does that make sense? SW clock on the bottom right. So this is GPIO 0 through 15 on the left side. So that's 0 through 15 on the right. Cool. Okay, cool. So what's this saying? What's this saying to us? So this is the actual chip, I think. So like there's kind of like this board, right? But then in the center of it is like the actual chip. So I'm assuming here is like what we're looking at here. And so what I'm curious to see is, do one of these like external pins trigger with the LED every time? That's kind of what I want to know. So if we go into the examples and Blink, probably I need to go to the right folder so that, I guess I have to ask CMake to cmake export compile commands or something. I think it's like this. And then I think that there should be a compile commands.json in here now. And this can be parsed by the language server. And so then I should be able to go into blink.c and... Oh, interesting. Still no. Oh, no, yeah, if I jump to definition on this, it goes to the right spot. Hype. Okay, cool. So what is GPIO init doing? Fuck. I should have known. I should have known. So this only goes to the header, which kind of blows. I want to know, like, actually what the fuck is happening in here. So I guess we kind of pivot to the SDK. Oh, no, wait. What did I also wanted to know what the pin was. That was actually the first thing I wanted. I forgot. So this guy's saying, yo, default LED pin is 25. I assume that these are the same as GPIO numbers, right? Because this is GPIO set dir. So we could make a guess here that the first thing is the GPIO number, which means that the LED pin is 25, which means that this is probably GPIO 25 down here. And then the question is does that map to an external thing as well? Which was here. Yes. So it would be interesting later to try hooking up to this pin on the right side here. This is GPIO 25. So, oh wait, hold on. Dude, I fucking hate websites that like fuck up zooming. Just let me fucking zoom in, dude. So, maybe I'm confused. Because here we actually don't see GPIO 25 exposed externally. Right? We see 20, 21, 22, then it skips 23, 24, 25, and jumps straight to 26. So that means that my guess at what these headers were, wherever the fuck we were a second ago, this must not be the right side of the board, because GPIO 25 goes here. So J4 probably goes somewhere else. Oh, this is pico W. But I'm sure that, like, I guess that connector goes to, like, a different part of the board, and we would have to, like, find that in the schematic somewhere. And I don't really want to do that right now. Okay, cool. Cool. So that all makes sense. What I wanted to try doing was, I wanted to try understanding what GPIO init is doing under the hood, right? Because if you read, like, this document, where was I that kind of... about this thing, blah, 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 who cares, minimal design example, blah, 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 flash storage. Somewhere I saw it starting to, like, talk about... Is this the right doc? This is, like, very hardware. Yeah, this is the wrong one. I feel like. I had a document open... Fuck. Maybe it was this one. So this is micro RP 2040 datasheet, and this is hardware design. Yeah, so I guess we want this one probably. Somewhere in here, it talks about how like controllers for different aspects of hardware are memory mapped in at some address, and you should just be able to like fucking slap those addresses to do things that you care about. Bus fabric. Yeah, it was somewhere in here. Somewhere they just start like fucking... Here, list of registers. So bus fabric registers start at a base address of this shit show. And if you just like scroll through this is like all of the hardware. Like how you interact with all of the hardware that this guy has. Right? So presumably, this like GPIO init function for this guy is like talking to some GPIO controller on the board and like asking it to do things, right? Presumably, that would be my guess. And so, let's see if we can like figure out what that's doing. So if we go into the SDK folder and start trying to figure out what GPIO init does, that'll give us a clue. And then we can start like trying to strip away kind of actual use of pico. We can try to like stop using the SDK for this stuff. We'll still be using the SDK for like runtime to get like into main, but I think that we can start trying to like rip out as much of this code as possible and start just like writing to addresses and see if we get the same behavior. Which means that we're probably around now, sometime before now. I guess we're kind of in this section. You're gonna need more than 2 beers to have fun control effing through microcontroller documentation. Yeah, well, 0 beers. It's fun no matter how many beers you have. Actually, I think this is just fun. This is my shit, dude. So let's look for like void GPIO init. It's promising. Where is this? Hardware GPIO, GPIO.c. This does not look promising though, because this is source host. So I guess they have some way for you to like compile your Raspberry Pi Pico code for your host machine and run it as like in like fake mode. I guess, probably. But okay, so this is RP2 common hardware GPIO. Okay, cool. And then it would be nice to get kind of this thing built so that we can kind of have like nice little jump to definition stuff. CMake export compile commands equals 1. How do you manage to do this? Do you just have a folder of to-dos? Yeah. One for each day? Yeah. And I don't ever look at them again. In reality, the real answer here is that I really embrace the idea of trying to do what I'm interested in, right? And so really it's just like, as long as I have a few ideas kind of coming up soon, I'm likely to have something that I'm interested in enough to start on like today, right? So I try not to plan too far ahead and then just kind of wing it day of. That used to stress me out a lot more. Especially when I was trying to put out a YouTube video that could hit the algorithm every day. Because now all of a sudden, trying to like come up with a titleable, thumbnailable chunk of work is like a stress-inducing thing. But if you take that restriction away, then it's really not that bad. It's really not that bad. If you like don't have something too concrete one day, that's not a problem. And there's always enough stuff that I want to do. That, it's not the end of the world. Like I'm never gonna run out, All right. So where was this guy? It was like probably this. No, it was in like RP2 common GPIO. Yeah, here's where we were. So this, I'm assuming, right? We're making like a pretty large assumption that RP2 common is the right spot. But I think that's a fine assumption to make for now. So this thing is saying GPIO set dir. He's got some mask, so he's saying, okay, if we're using coprocessor, which I don't think we are, else if we're the RP2040, which we are, so we're in this case, which we can tell by the fact that everything else is grayed out. Okay, so here he's saying set the direction to out with this mask, which is just the GPIO shifted left by that number. So there's some bit mask somewhere that we're setting. And this guy goes to SIO hardware GPIO OE set. So where does this come from? This is a struct in RP2040 SIO.h. And so they just like typedef this struct. And oh, that's clever. Oh, that's kind of fun. So they just like, so they have this struct, SIO hardware T, and this goes to SIO base, which is here. And they just fucking cast that shit. And all of the offsets just like should fucking line up. That's kind of hype. And then this is just a volatile UN32. Cool. So that shouldn't be that hard for us to replicate. So we just need to probably double check docs here for like what this is supposed to be. So this is 0xD. Interesting. So this is interesting because we were looking at, we found this shit, right? That says like, hey, we're at 0x400300, which is kind of like all of this stuff right? But bus control base here. But it looks like this is using something called like SIO. So processor subsystem SIO. The single cycle IO block contains several peripherals that require low latency deterministic access from the processor. Is it accessed via each processor's IO port? This is an auxiliary bus port on the Cortex M0 Plus, which I assume is the main CPU. I've also been hearing some stuff in this datasheet about a coprocessor, so I guess there's a second CPU on here somewhere. This has a dedicated bus interface for each processor's IO port, as shown in Figure 7. They access this with normal load store instructions directed to the special IO port address segment, this. Here we go. So that's a good clue, right? So we should be able to be like, define thorough SIO base. We're going to slap my name in front of it so that it doesn't conflict. And we'll just copy paste this, I guess, right? I think I missed a 0 on the copy. Okay. Step 1, done. Then, presumably, somebody's going to tell us what those mappings are. GPIO control. So we have access to GPIO registers for fast and direct control of pins with GPIO functionality. There are 2 identical sets of registers. GPIO X and high X for direct control of this. What the fuck does this mean? Oh. So SPI is like another bus interface. So I guess this is like... I'm not sure. Not sure. IO bank 0 and QSPI IO bank. So I guess that just means that there's a... Does this help us understand? No. I guess it would be interesting to look at where SPI lives on the schematic. That might give us a little bit more of an intuition there. I'm assuming that it's just a different... Like, the fact that he's saying second IO bank makes me think that it's just a different thing. I don't know what's with the HI names. But fuck it, I guess. Do you have the Pico or Pico 2? Pico. First one. It says 2020 on the board printout. And we can also double check with Pico tool info-a.f. No, because I have to actually reset this thing now because it doesn't have the USB subsystem initialized. 2040, baby. Okay. So does it tell us how to like interface with this thing in the datasheet here? It's got a bunch of code examples. Okay, here. So output registers, we have GPIO out, which is a hyperlink here. Ah, nice. Okay, this is the fucking shit, dude. So where are we? We're at like page 45, which is like, where is this? Just in like a register list? Where the fuck are we? 2.3 processor subsystem. If I just scroll down from here, do we get there? Like another 10 pages. Oh, I see. So it's this SIO block is like really long. Sure. So it's like if I just keep scrolling down, we eventually get there. Gotcha. Okay. So GPIO out register sets the value. Out set register. Whoa. Okay, hold on. Set output level for GPIO 0 to 29. Reading back gives the last value written, not the input value. If core 0 and 1 both write to this simultaneously, the result is as though the write from core 0 took place first. Okay. So they're calling... To initialize the thing as an output, they're calling OE set, which comes after OE. Oh, here we go. Output enable. Ah, here we go. Okay, cool. So GPIO output enable register, set output enable for GPIO 029. What's the difference? Oh, interesting. So this is the actual bad boy. This is the guy who like configures whether or not the GPIO is set as an output or an input. But this guy is like a hardware enabled atomic write. So this way, you don't have to set the whole mask, right? So if you're running this guy, you have to read, modify, write, and you might be doing that in a way that's unsafe because you have a second processor that might be slamming the same fucking thing. So this is a way for you to do like, say like, okay, I'm only trying to modify this specific pin. Let's do that. Okay. So this is offset 0x024. So this is GPIO OE set. Okay. Cool. And so we should be able to like, I don't know, write SIO reg, I guess. And this is like a pointer to a uint32t. Addy. Val. Okay, and this is just like addy equal val. Okay, sure. Fuck it. And then instead of doing this, GPIO, and it only set the thing as an output, right? He called set dir on this thing, and then he put a 0. Oh, and then put the function. Okay, so this should be like set dir, put set function. So set dir, we know how to do. It's like write SIO register of Sphero SIO base plus Sphero SIO GPIO OE set. This is the offset. And we're setting this to 1 shift left by, we need the LED pin, which was 25? Which I guess we should confirm in here. LED? Like, where does that information come from? That would be on like the actual board schematic, right? So I don't know if like RP2040, I'm assuming that's like the actual like CPU thing, like the like I guess it's easiest to show if I guess it's easier to show here. I assume this thing here is the RP2040. So I don't know where I'm supposed to tie back the information of like maybe schematic here. How we get to GPIO 25 here, which goes to WLCS, which, oh no, wait, is it the wrong one? It's the numbers don't line up very well. This is a little below. Yeah, so this goes to WCS. Don't know if it matters, but you were looking at the schematic for Pico 2, not the Pico. Oh, that probably does fucking matter, huh? Yeah, that's a good fucking eye. Good fucking eye. I don't want the pinout. Step file. I want like the fucking, I liked that schematic link. That was kind of hype. I don't want to like download design files. Like, I don't, unless these have PDFs in them. Oh wait, no, they do. Hype. Never mind. This is exactly what I wanted. Okay, GPIO 25. It's labeled GPIO 25, which goes over here to a green LED. Hype. Okay, cool. So we've tied back now this information. We know how to retrieve this. This is from the so we can say this is what is this thing called? RPi pico design file schematic. Okay, so then we're like shift this motherfucker by this much. And this we have to probably cast to if I do this, Is this allowed? Like, does this do what I think it does? I never know the fucking rules for C. Or if maybe I have to write volatile void here so that it doesn't like do something stupid. Or do maybe I do volatile uint 32 uint 8 void star this. That looks promising. It's not like airing out on me anymore. What happens when you do pointer arithmetic on a void star? Like if I'm like I guess this is C++, which doesn't help. Test.c. Main void star a print equals 0x 100, and then we do like printf some pointer value of a plus 4. What does this do? All right, GCC test.c. Okay, it does byte-wise. So that means that everything's probably fine. Right, because now in wherever the fuck I was, blink.c, right, I have this guy set up as a volatile void star, but then I add 24 to him, but that's done by like as single byte offset, not like it's not like multiplying by something. Like if this is a uint 32 t star, that would be a problem, right? Because it would move 24 uint 32 t's ahead, but void star is moving 24 bytes ahead. Then we could probably do this, and it will autocast. Cool. Okay. So this is like a set LED pin as output. Then they wrote the value of 0 to that guy. So that's fair. You probably do want to do something. So here they're taking the mask, and they have set and clear. Set and clear are the two options here. So is this guy SIO? We're looking for something that like sounds like GPIO set and GPIO clear. Here we go. Out set and out clear probably, right? So we probably don't even have to fucking read these, right? Probably. 14 was set and clear was 18. Okay. So Pharaoh, SIO, GPIO, clear. So we write the 0 here. Okay, so this is also superfluous. Is that the right word? Like, they don't have to do this shit because we see that it was done by init. Wherever the fuck that was. Right? Oh, whoa. Oh, whoa. They set it to an input first. Oh, that's interesting. Then they put a 0 there? Interesting. I mean, I would assume that we don't have to do this. I would assume. What's the reason for this? I guess if you GPIO on it and then immediately read, like what happens when you call put when it's set as an input? Let's read that. Okay, that's not helpful. GPIO out register. Reading back is the last value written, not the input value from pins. If core are both set to out simultaneously, blah, blah, blah. The result is if... so this doesn't say anything about what would happen if you wrote this when you're in read mode, right? When they call it set, it's when they call setter in, they call OE clear. So output enable is just whether or not we want to. Reading back gives the last value written. Yeah, I mean, there's nothing really that interesting here. So we could maybe guess. I'm interested to see if we ignore what they fucking do, if what they do, and we just do what we think makes sense. I wonder what'll happen there. So we say, you make this thing an output, write the fucking value 0 to that guy, clear him, and then what does this set function do? Okay, this is probably pretty important, right? So I think what this does is these pins are multi-function, a lot of them, right? So like this guy, GP17, he can be an SPI interface, he can be an I2C interface, he can be a UART interface, or it could be like a standard GPIO. So this set function is probably configuring the SIO interface to like pick which one it wants, right? So here they say GPIO func SIO, select SIO as GPIO pin function. So this is probably important for us to do. So check param, who gives a fuck? This is the actual interesting part. Set input enable on, output disable off. But why is this GPIO set function? Shouldn't, like... Oh, I guess they're kind of saying that, like, the USB pins are on a GPIO or something. Sure, fuck it. Okay, so they have pads bank hardware IO. What the fuck is this? So this is at address pads bank 0 base. So can we search for like 4001 in this thing here? 4001 C. Pad control. Yep, okay. So this is just somewhere in some fucking mega list of registers. So like, what the fuck is pad control? Select an IO function. Okay. Like, what does it mean? What does it mean? Is this where we ask the idiot? What does pad control mean in the Raspberry Pi schematic? Like, what is this like document called? Raspberry Pi RP 2040 data sheet. Question mark. Let's see. We're not going to trust him, right? But he might give us a clue. Configuration of management of I/O pads, input output pads on the chips. So that kind of lines up with our guess. He has a bunch of configurable I/O pads that can be used to connect the chip to external devices. Blah blah blah. So we might be able to set like, oh, interesting. Oh, okay, sure. So we can say like, do we want this thing to be pulled up? Do we want it to be? Okay. I mean, we'll see. We'll see if that's true. But these are like some reasonable guess. That would make sense, right? So for like, this thing should be driven at 3.3 volts instead of 5 volts, and you know, how fast is this thing gonna fucking move from a high to low? And when we're reading input, like if it triggers on and off, like are we going to wait some amount of time? You know, should this thing, like if nothing's plugged in, should we read high or low? That makes sense. That this is all like things that like you would need to configure, right? I get that. So if that's what this pad is, that makes, I'm fine with that. Like I have any fucking control Like I'm in charge in any way, shape, or form. This was the wrong fucking thing. This is a really. Wait, was it? Yeah. Where were we? It was this one. RP 2040 datasheet versus Pico datasheet, of course. Okay. So he's probably setting pad control offset by some GPIO. Okay. And he's writing this thing masked. He's setting 1 bit. There's 1 bit that he wants to set on this thing. Oh, no, 2 bits? Yeah. So input enable bits and output disable bits? Maybe? And he's setting this to... okay, so this is him, like... Set input enable on, output disable off. So he's asking the controller to enable both GPIO input and output functionality? Okay. And then he sets the control fields of this guy. So before he was just calling IO. Then he goes IO. So this is pads bank and this is IO bank. All right, interesting. And this is like, okay, let's try to figure out what these things mean. So we're on like GPIO 25, right? Not that it fucking matters. But okay, so we have these bits. So we have drive strength, input enable, and output disable. Cool. And so when he says like write masked, oh, this is doing a read. He's reading this thing, then XORing with the thing we're writing. Oh, and then he's calling hardware XOR bits. What the fuck? Oh, holy mother. So we don't have to be that fancy. I'm sure that's better, but we could do like, so we need to like read GPIO 25 pad bank 0, right? We need to do that. Then we need to clear the output disable bit 7 and set the input enable bit 6. And here we're like, well, probably doesn't matter. Right? That'd be my guess. Is it so you can just add 1 bit and stuff kind of thing without having to do the bit math? I think what I'm seeing here is that like there is actually a thing in the fucking CPU that you can call out to do this XOR, right? So here they're trying to say flip the values of these things, I think. And they're asking the hardware to do that thing for them, I think. But I think that we can just read that address. So we need the pads bank root address, which is this. Sphero pads bank 0 base. Okay. Then we have Sphero pad 0 GPIO offset. Oh, well, this probably won't. Let's be like volatile void star again, I think. And we need to find the offset for the GPIOs in here. So GPIOs start at 4. And then our GPIO is that plus... Can we do like define sphero pad 0 pad GPIO adder or something? And this is going to take in like num. And then can we do like sphero pads bank 0 base plus 4 times num? I think that makes sense. Right, because these things are spaced 4 bytes apart, starting at 4 bytes offset from the pad control base. I think that does what we want. Okay. So... do we return this as a volatile Uint32 T-star? That seems kind of nice. That seems kind of nice. So then we should be able to just be like... volatile Uint32 T-star. This is the GPIO pad. And we pass in the LED path here. Yeah, that makes sense. Then we read this thing. Uh-huh. Then we say like GPIO pad, we want to this is reset values? Oh, on reset, this thing starts at 0. And this thing starts at 1? Is that what this is saying? In which case, do we even have to do anything? Right, this sounds a lot like we don't have to do anything. I'm assuming that's what the reset field means here? Yeah. I'm assuming that this doesn't mean like call like write this value to that thing to reset it. I'm assuming that's not what it means. It could be. But I think defaults makes a lot of sense. That would be my guess. In which case, we can kind of just say like GPIO init in SDK sets what do we call it? Like disables GPIO disable and enables GPIO input enable. And you could make an argument there that it makes sense because you might do something like set this thing up as like something, right? And now I want to use this thing as like GPIO. So it might be in the wrong state. But we know from the RP2040 datasheet, I'll put no in quotes because the datasheets are often wrong, that these start in the state we want them in. I think that's reasonable. Okay. So now we just have the last part of set function to deal with, which is 0 all fields apart from fcell. We want this IO to do what the peripheral tells it, as these are in pad controls. Okay, so what is this? IO bank hardware, IO bank 0 base, which is 400 14000. What the fuck is this? Here we have 36 multifunction GPIOs divided into 2 banks. In a typical case, the pins in the QUISP bank are used to execute code from external flash device using the user bank, this stuff, for the program to use. Okay. All GPIOs support digital IO, but 26 or 29 can also be used as inputs to the ADC. Okay. Sure. Oh, I see. So this is like, you could read values that are a variable voltage range. Sure. So we function select this shit by writing to the functional field in the GPIO's control register. See this as an example. The functions available for each IO are shown here. So we are on 25, right? And we want 25 to be set as SIO, function 5. Okay. Cool. And so then we go to GPIO control, and here is kind of everything, right? And this comment in their thing says, fuck it, right? They're like, fuck it, zero everything out. They're saying nothing fucking matters other than function select, right? So here we write SIO was bit 5, I think. GPIO init. So this should say 5. Nice, good. So, wait, where was I? GPIO init. Hello? Where the fuck am I? GPIO.c, GPIO init. So they're just setting the control field to 5 unconditionally. And so they're saying nothing else matters because, like, what? Because it's an... I mean, this stuff sounds important. Like, do I want to enable interrupts? Input over. Invert parry. Drive parry at put low. All right, I mean, we can just trust them. This, it seems to me like that's not okay, but we can trust them. So we'll just say, we need define Sphero, like, what is this shit called? IO bank 0 base. Which should be this. We should probably put all these things in brackets just in case. Then we want, like, define Sphero GPIO, like, IO bank GPIO control with a number again, right? And we're looking at 4, so we're looking at the base. Plus 4 plus 8 times none, I think. And then this thing is like a 32-bit register. So volatile unit 32T. Sure. Blaze it. Okay, so we should be able to just, like, set this thing now? Right? He's just saying set this fucking to 1. This is not an SIOX, so we're calling, like... We're saying, like, take this thing at the LED pin and set that shit to 5. And we'll just say set multifunction as SIO. SDK code in GPIO init claims that it's fine to 0 everything else out. Even though that seems weird to me. Okay. We shouldn't have to do this. This stuff should go away. And fuck it. Okay, so now we're kind of hoping that if we just compile and run this again, it still fucking works. I guess that's kind of like the ideal world for us. Make blink. Uh, blink, you have to. And I see no blinking, which means that we fucked it up. We done fucked it up. That's kind of fun. So we go back to GPIO init here with GPIO set dir. And we try loading again. Surprisingly, that's not blinking on my eyeball. Like, that's not working either. Oh, because I didn't build, huh? That would do it. Okay, so that's blinking again. And I feel like I don't have to prove it to you. It's just a light that's blinking. So I think that the plate here is to try to kind of do this a little bit slower. Right? So maybe we kind of copy paste the entire GPIO init block and try to work our way up. Building code, so picky. I know. I know. So I think that's the next play. Is clearly we suck ass, right? So can we just kind of replace this with, you know, this? Okay. Make. And then we upload. So that's blinking. Trust me. You can trust me. I don't want to have to fucking tilt the camera down every time. Okay, so something that we kind of did was we just didn't do this set as input. We kind of did this, right? And we kind of thought this should behave the same way. Set the direction to out, don't write anything, and then set the function. So I'm curious. Oh, fuck. I mean, we do need to build the code that we want to run. And we need to remember that, or else we're going to make bad conclusions. Right? That's just going to happen, so. Okay, so it is blinking again, which means that that's also fine. Right? So now we should be able to do this. Right? Where we believe that this should be the same as set, right? So if I comment this out and bring this stuff back, make, and then upload. That doesn't work anymore. So this is not doing what we thought. So either we're fucking it up, or, okay, so this goes shift 1 by GPIO. So that should be fine, assuming that this is the same number. Fuck. So let's actually start also. Let's just double check if we slap a sphero in here, which we believe should be the fucking same. You know, let's just double check that one as well. Not in boot cell mode. Shut up, dude. Fine. Fine. If you want to program the thing, you need to be ready to program. Fine. Okay, so that works. So it looks like here. What have we done wrong here? So in setdir, we have out as GPIO in, which is 0. But we're calling out, which is 1. So we have if out, which is true, set this, which is just writing GPIO output enable set to that thing. And then is he doing anything else? No. So this should be equivalent to this unless we just fucked up. So let's look again. So this guy's writing to SIO hardware, which is at SIO base, which is at D00000. So that's what we have here as well, supposedly. And then he's at some offset. OE set, right? And he's just writing that to mask. So what are we fucking doing wrong here? Interesting. This is super surprising. Okay, so SIO base, let's just make sure that like SIO base, let's just double check our copy paste of numbers here. So this should be D D0 0 0 D 0 0 0 0. Oh god damn it, I can't fucking count, man. 1 1 2 3 4 5 6 and then D0. 1 2 3 4 5 6. Fine. Copy pasting's so fucking hard. It's a hard life out here. Okay, let's try that again. So our suspicion there is that we just got the address of the SIO base wrong and we were just writing to some other fucking piece of hardware. Classic! Oh, it's blinking again. That's so fucking hype. So we can go back to trying to set the GPIO function ourselves as well. Let's see if that still works as well. Pico tool. Also working. And so now I think we've kind of got all of the init stuff. Shifting into UI, UL maybe. I think it's I'm not really sure what you mean. I think it's just that I copy pasted wrong. I think. So this goes away. We don't even really need to do this clear. Set LED pin as output. Yep, sure. Yeah. And then we can say like set initial output to 0, but like maybe we don't need to do this. So now our set LED is this. If LED on, we set it, else we clear it, right? So do we have set here? We do. And so now where were these like GPIO functions coming from? Oh, probably this include here. Okay, so now we can't fully remove that include yet, but we're definitely getting closer. We're not calling anything here. Let's just see if this works. Pico tool. Nice, so it is still blinking. Hell yeah. So now we're not really using any of their GPIO subsystem at all. We're kind of doing it all ourselves, which is super fucking sick. And then let's just kind of so here we can return 0 to kind of reduce some more dependencies there. And we can just kind of comment that out, fuck it. Then we set this and set this. Okay, so sleep MS. This is probably the next thing to look at. Sleep MS. So this is probably like void sleep MS in pico time.c, sleep US, sleep until. Busy wait until sounds hype. Let's just do that. So here we have some timer, probably in hardware. Let's kind of say that we're moving on to sleep. And kind of in here, it was probably like remove, do GPIO handling ourselves. Okay. So they have It's so funny it takes 8 layers of digging to get near an actual address. Yeah, I mean, this is just the way it goes. I mean, they're right to do it the way they're doing it, right? What we're doing is like not what anybody wants, right? People want to like buy this thing and like use it, right? But I am just having fun poking around trying to see like what's it actually doing because I think that's more fun. And I think it's reasonable that it's like not really that like this isn't what they're shooting for, and even this is not that bad. Uh, Busy wait is just like processor spin rather than sleep wait IRC. So I think that what they're doing is they are just doing noops, right? But their no ops are like their exit condition is not determined by calculating the number of times you have to do a no op and spin the processor, right? I think what they're doing instead is they are just like reading. They're allowing to read the hardware timer, which should give like I don't know if there's I know I don't know if like processor clock rates are like super steady or if you can like assume that this thing will run at like 1 tick per frequency, 1 tick per tick, I guess is the right answer there. So I think what they're doing based off of just skimming this code is they're saying there's some piece of hardware that we can read to get a timestamp. And we're just going to like wait until that time. Like we're just gonna like wait till it has a number in it. Instead of using like an interrupt based mechanism. So we should be able to just read that timer the same way. So like, what the fuck is like default timer instance here? Timer hardware, which is timer base, which is this. So we should just be able to like copy paste this shit into the datasheet and like search for that shit. List of registers, time HW. Oh, okay. So this is interesting. There's my guess here reading these things is that H and L are high and low bits of this timer, right? So we can only do 32-bit reads and writes from this whatever the fuck we're reading from, whatever like memory mapped piece of hardware this is. So you have to, if you're trying to read a 64-bit number, you have to chunk it up. And then I don't know what the R versus W is. This is from time. This is time HW. Can we look at like time LR? Can we get like more information about this? No, time HR. Oh, here we go. Here we go. So this means the time values access to a pair of registers. These are this. These pairs are. What am I like? These pairs are used by accessing low register L followed by higher register. Right. In the read case, L register latches the value in the H so that an accurate time will be read. Sure. Alternatively, A, and you throw an A in there, it's not latched. But why are there two counters? That's what I don't understand. I guess you could maybe set them? Ah, yes. Okay, so they're saying it is technically possible to force a new time in the W variant, not the R variant. We don't fucking do that because it's expected to be increasing. And I bet that the alarm system is based off of the values in the other one, in the R one. So you probably like set this to something and then say like trigger an alarm when like blank thing when like time hits, and then that will fire like an interrupt on an interrupt vector. That's my guess. Right? So when you would like when right at the time you would like to interrupt to fire to alarm 0. Plus your yeah. And then yeah, they're not saying like don't write to this one. They're just saying don't write to that like the W one. Okay, so that makes sense. You have two counters because you might want to like trigger two alarms on like two different, things. Sure. So reading LW and HW seems reasonable to me. And like, what unit is this thing in? These like, sure, but like, what the fuck is it? Surely this is like incremented at some like number of CPU ticks or something, or like every n clock cycles, this thing goes up by 1. I assume it's not nanoseconds, right? Uh, so time microseconds, timer time microseconds. Assuming US is microseconds, it probably is. So they get like okay, so this is also wrong according to the spec or according to the document, right? They're saying that if you just read low and high, then it latches and you don't have to do this shit. But I mean, this is common code, so it's possible that on other variants, the hardware doesn't do that for them. So they're reading high, then reading low while they read high again, and high is the same, right? So they're going like, read the first half, read the second half. First half changed, try again, right? And this spec is saying, don't fucking worry about it, bitch. I think, or was it the other way around? Oh, W is write to bits. Read. Oh, maybe R is read and W is write. Oh, always read from low before high, and then they started latching. Okay, so we should be reading all the low one. Oh, they're also using the ones with A's for like non-latched variants. Sure. But why are they reading? They're reading from the right one? Do they have like time HR, time LR? So can we look for like uses of time LR in here? No, nobody's using that shit. Okay. Fuck it. Let's just try reading. Oh wait, did we figure out the units? Microseconds? It sounds like they're just using those things as microseconds, right? They're just returning high and low. So I think we can assume microseconds as well. Okay, so this guy is at like timer base. Volatile void star this, okay. And then we have time LR and HR. We're supposed to read which one first? L first. Define Sphero timer time LR is this plus 0xOC. Yup. And then HR is 08. And then if we're like unit 64T time, like read time, Sphero read time, I guess, to avoid name collision. We do Sphero timer HR HL and then return can we do this as like return H or L? Okay. So then our sleep should take like we go like unit 64T start is read time while Sphero read time is less than start plus LED delay ms times 1,000. Yeah. Sleep time. I guess it's like this. Okay. That sounds kind of hype. Right? Fuck it. Let's see if that works. Let's see if that works. The thing turned on and is never blinking. So either the sleep time is like never getting hit. Like this might just be looping forever. Right? That's a very real possibility. So let's... Okay, if I like just comment this shit out, I assume that I'm gonna see the light like really flickering like fucking mad. I'm not really seeing that. MS or US? I think it should be microseconds. So that's why I'm like multiplying by 1,000 to get to microseconds for milliseconds. Okay. So oh sure. So this doesn't actually do anything. So they're tight loop contents. I feel like what we did is kind of sane. How do we like... So there's lots of reasons that this could be broken. Right? Hand wavy. Like lots of reasons. So can we do something that's like... Oh, it would just be so nice if we had like the debugger shit hooked up. But I bought it. I like ordered it today, so I don't have like an ability to like actually hook up GDB to this shit. But like I don't really know how to like debug this other than by just like inspecting. We should be careful about these addresses again, right? Because we've copy pasted before, and we did fuck that up. So it should be 00054 00054 So that seems right. Then we read 8 and C for HR and LR. So that seems reasonable. So if we assume that this stuff is moving up, then it becomes a question of this. So we could try just like playing around with different time periods here and see if that does anything. I guess we have to build this before we actually like, oopsies. Okay, so what happens when I run this? The LED turns on, and as far as I can tell, never turns off. Okay. So say we were to like return 0 here instead. With sleep ms here, right? What I would expect to see here... Oh yeah, flip the loop. That's okay, that's a better version of what I was trying to do. I agree. So if we flip this, we're hoping that the LED stays off. Well, not hoping, but that would confirm the idea that we are never exiting the sleep. Which is in fact what I'm seeing, is that the LED is forced off. It's never turning back on. So that really like makes it sound like this is just not changing. So can we try Okay, if I return 0 here, and then set this to true, and then use the real sleep function, I'm hoping that this turns the LED on, and it stays on. Right, that's kind of like would be nice for me, because that would mean that we can kind of see if we're toggling really fast or not. Yeah, so the LED is just like stuck on right now, which is hype. So what I want to know is I want to say, like, while this is the same as the start time, keep going. And I want to see, oh shit, sorry, I actually want to turn the LED off. Right? So here, what we should see is that, like, the LED turns on, and if the LED stays on, it means that we never fucking exit this function. But if the LED stays off, then it means that we successfully slept, or like we successfully like escaped the loop. Uzaten, thank you for the tier 1, much appreciated. Okay, so this is in what I'm seeing right now is that it is stuck on. Stuck on, which lines up with our idea that our like time function is just like not fucking working, right? No timer base and read time. Timer base is here though. So the fact that this isn't changing is not a good sign. Not a good sign at all. Now, we do have to remember that nobody in the SDK is reading these values. Right? So there's something there. There also might be something about I don't know what the integer promotion rules are here. It does say always read LR before HR. Did I fucking get it backwards? It sure did say that, huh? And I'm also worried about like integer promotion rules, so doing this feels like kind of more reliable. Oh, and then I'm a dumbass. We did forget to shift high. So kind of just like 3 things at once that could have been wrong. Okay, make. And flash. Okay, so this is still stuck on. Which is very interesting. It's stuck on, and so let's just confirm that I do expect it to be off in the happy path. If our sleep function worked, yeah, it turns on and then immediately off, which is kind of what I would expect. Okay, so that's really interesting. And here, we're just saying, like, while this time is the same as us, get the fuck out. Always read LR before HR. So we read LR as a UN32. Oh. Fuck my life, dude. That might have an effect. We did just forget to write the word volatile there when I cast it. Oopies. Alright, let's try again. LED's off, which is really good. Really good. So we should be able to go back to this. And that should work. Make. Load. I do have to unplug this thing and restart it in program mode. Fuck. Oh wait, this is wrong now. This should be, while this is less than start plus sleep time. Try again. Doing it. Bum, 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 bum. All right, and then load. Let's go, baby! You see that shit? You see that blinking motherfucker? Let's go! Let's go! So now, are we totally decoupled from the standard library now? If I like don't include anything from there, and we include like a std.int.h. Oh. So we are not so lucky because this guy has probably like defines for how, like, where's uint32 and uint64 defined? Here. Oh. Wait, but that's kind of fine. This is in glibc. Oh no, wait, that's fine. We should be able to do this. It says it can't find it, but I think it's lying. I think. Make? Yeah, that's compiling still. So that's pretty hype. So now we have no dependencies on them, right? Which means that like we should be able to compile this without their build system, right? I think that's kind of like the next thing that we kind of hype. If we said like build without build system. So where the fuck? How the fuck did they compile this thing? Make clean. What do you think bro's doing? Okay. Verbose equals 1 make blank. So it looks like a lot of this is compiling SDK shit. But here, don't think so. Usually embedded SDKs either run the user application as a library that gets linked in the SDK application. Yeah, but we, like, their build system is doing something, right? They're calling this, which is saying, like, run G++, that's crazy. My CPU is like this Cortex M0+. We've got thumb instructions on. We're defining some, like, typical shit. I don't know what this is. WLMAP. I don't know what that is or what specs is. And then we have like a bunch of wrapped functions. I think I saw in here, like in the docs. I saw something about like it not even having like integer divide, and integer divide being like implemented as like a hardware function that you write to a register of, and that the SDK like overrides like built-in pop count and like all of the like shit that you would like expect to be part of the compiler. It like overwrites that shit, I think. Yeah, here, this is where I saw it. So they're like, in general, you do not need to call these directly. Oh, this is, sorry, bit counting manipulation functions. Maybe it wasn't divide. Maybe it's only this stuff. But they're like, yo, there's like some stuff at like boot ROM functions, and they have like fast versions of like memset and shit, where you like look this up as like a function pointer somewhere. But, and so I think that's what these like WL wraps are, is they're saying like, can we look for like memset in there? Right? So yeah, like this, right? They're saying like, hey, we're going to like make memset do fucking something else. Not what you would expect, right? So all of this is them just saying like, we got some hardware shit, baby. This is like a linker path. Here they're saying this is probably like the most interesting part of this whole thing, this linker script. So they are making like a very fancy elf. That is like, it's not like an executable that you run on your desktop, right? It's like, presumably their bootloader is going to like, when the thing starts, it's going to like load the contents of the binary from Flash, put it in RAM, and jump to like some expected address or something. So I expect that this linker script is like setting up a bunch of rules on how this binary should be set up that are different than normal. Right? This is probably also interesting, right? Max page size 4096. That's, I assume that that's relevant. And then this GC sections is just like get rid of stuff that we didn't use. A lot more rappies than like SDK shit. That seems like something that we could compile. Okay, let's start here. So let's copy this whole thing and let's just start like going into our blink and call this compile sh. He is not happy. Why the fuck not? Is this command like too long or something? Copy. Paste. Oh, there we go. Why is this multiple lines? Join. Okay. So bash compile sh. LD failed. Oh, sure. But we're trying to remove all of that like SDK shit anyways. So all of these like .os from the SDK, we like don't need that shit. So wait, where is he? He's like compile sh // pico SDK. So oh, it's only one thing. Everything else is okay, what if I just didn't like let's start there. Let's just delete that one thing. Bash compile sh. I guess it makes sense for us to actually start in the correct directory and then work our way down. So we should be like here. So you're saying this doesn't exist? Okay. Can we try this again? I'm not really convinced that I copied the thing right. I think what we should do is we should start by literally just copying this line and seeing if we can run this fucking line of code by ourselves. Copy. Paste. I think. Yeah, okay. Bash compile sh. Okay, so he's pissed because like this didn't copy paste correctly. This didn't copy paste correctly. Why not? Why not? Am I losing my mind? Can we do like T compile.sh? Okay, and then can we just like delete everything except for that one line? Make clean first. So it actually has to build it. Okay. Give it a sec. Okay, compile.sh. And we just want to delete almost everything all the way to like the fucking bottom. Right? Like what we're looking for is like this like actual interesting compile command of making the elf. Blink elf. Okay. Okay. So it should just be this. And then it looks like this should be run from a folder up. No. Cannot find this. Why not? Source? Like, am I stupid? No, it doesn't exist. Oh! Hold on. maybe they built the SDK as part of this thing. Find build dash iname pico SDK. Type F or D. Ah. Okay, that's interesting. Can we see like what directory that was run from? Make blink t compile sh. Is there like make force rerun? Make verbose equals 1 make dash b blink t compile sh. Okay. All right. So all these entering directory are probably also interesting. So here we're running from here. And then we cd to blink and we run all this shit. Okay, and then linking. So this is oh wait, hold on. Wait, what's this? cd to blink and make this cmake link script link.text. What's this? Link. Link.text. Wait, this sounds hype. Is this the directory I'm supposed to run this from? No. So here's what I'm really we have to figure out. Oh, here. CMake files blink dir home streamer. So here we're supposed to do bash CMake files blink dir link.text. Oh, that's a good clue. That's a fucking good clue. Okay. So can we copy this? Here we go. First of all, let's make sure that blink.c is in here. Oh, this is blink.c.o. So if we, let's say that we just wanted to compile blink.c as part of this. Home streamer pico work pico examples blink.c. Yeah. No. Why? Oh, these are just warnings, and then errors f permissive. Really? Invalid conversion from volatile void star to unit 32 T star? Really? Is it because I'm using G++ instead of GCC? Ah, it is. Okay, cool. Cool. So now we're compiling like the file itself. And we can start like trimming it. So I guess we also need to try uploading this thing. So I think there's a way to like turn the elf into a UF2. I think. So now we have blink.elf, and if I try to upload blink.elf instead of blink.uf2, does it still work? So I say like pico tool load-x blink elf. I guess it needs to be pico tool. There we go. Yeah, okay, so that still works, which is pretty sick. So now we have like a test that we can start doing where we just start trimming this down. So we can copy compile sh to compile back sh. And we can start like, I assume that like all of these wrap things are not needed. Boom, 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 boom. Because these are kind of like, I don't think we're using any of these functions right now. Maybe we would want to use them eventually, but for now, we're only just like writing to a GPIO. So all this shit, who fucking needs it? Who needs it? Get the fuck out of here. Oh, that was something else. Well, a few more rappies. Okay. Then here, this is like a bunch of standard library files. I'm curious to see what happens if we just don't fucking include them. So if we kind of comment this shit out and kind of take the part of this command that matters, which is write to blink.elf. I want to know if that still compiles. No. So we're missing some functions. I wonder why. Because as far as I understand it, like, as far as I understand, we're not calling any functions like write or anything, right? But maybe these like pointer dereferences are turning into those. So I'm curious to know like where like close R is coming from and stuff, right? And like what it does. So like, can we grep through the SDK? They're not really in here. Were they in some of those like... No? I'm not seeing like close R or read R anywhere in there, which is kind of interesting. Oh, okay, so this is... Oh, this is kind of interesting. So this is saying like if you have no floating point... What a crazy huge compiler Arglis, yeah. It could be that like the default implementation of some floating point functions are not implemented. And then, but these are kind of just warnings, a lot of these. This is where it's getting to be interesting. Pico's second stage bootloader must be 256 bytes in size, and we're missing the entry point symbol. So our program is written as like int main void, right? But that's not actually what fucking happens, right? So if we look at like what's like the best way to show this? I think we kept the linker script in. So if we look at this guy, this is like the definition of how to run the linker, right? So you like you compile your code, the executable part of it goes into like some binary that like has a way to find this thing called like .text, right? If I call like readelf.h on blink.elf, it doesn't exist because we deleted it. True. Let's do like test.c int main void and return 0, right? Let's just do a really simple executable. gcc-o test.c readelf.h -h on test, right? Readelf dash. I thought, how do I get like the fucking section headers? S, right? So this guy, he's got like a bunch of like different areas of code, right? Some of them are like text is like where the code actually lives, right? And so like text will be loaded at this address. But like when you load the elf, you have to like know where to go, right? You need to like know how to fucking like start running code here. And so one of the things that the elf says is like, hey, when you start running, jump to like this address, right? And if we like start like disassembling this guy, what you find at that address is not main, but usually something called like start or something. And the linker script can like define an alternate entry point there. So if we look at there, they're saying, hey, we want you, elf file, when you run, start at this fucking function entry point. And now it's like, what the fuck? That doesn't exist. Also, he's complaining that boot 2 doesn't exist. So probably boot 2 and entry point are provided by some like runtime or something, right? So, right, and we can see CRT 0. This is our typical like C runtime 0 or something, compiler runtime. So I bet you that there was another file in here that had CRT 0 in it. Right here. This motherfucker. And I bet if we add this guy back in, that's going to help us a lot. Just a guess. Okay, that's a lot better. Maybe it's not. That fixes the entry point log, but not the bootloader thing. So presumably the bootloader is also in this original compile. Like if we say like bootrom.c.o sounds kind of boot stage 2. That sounds like boot 2. Let's try that one. All right. That fucking compiled. That compiled, baby! And let's see if that's flashable. Looks like no. So it did flash, but he's just like fucking falling over. Right? I don't see any blinking happening anymore. Which makes me think that those warnings are likely relevant. Can we like disable floating point math or something? GCC, like I know the kernel doesn't have floats. GCC disable float. M soft float. I don't want soft float. M no float. You can try it. Wait. There we go. I'm just looking for like, oh, maybe it's the O3 as well. Might be trying to do like SIMD or like neon shit. That's possible. Yeah, can we turn off optimizations? Still no, huh? It could be that like somebody else is trying to use those guys. If we like nm-c on link.elf and look for like right. Oh, they might not be externally exported. Are we missing a final stage of the compilation? I mean, before it seemed like when we did like compile back and we uploaded this thing, that seemed okay. Right, so if we do pico tool on this guy, I do see blinking. Blink, 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 right? And so my assumption here is that if we do the same thing with our compile script and it doesn't working, dude, am I fucking like high? If it doesn't work, then it's a problem with like us missing something. Can we adjust the LED to be on by default just to see if it's working at all? Yeah, it's not a bad idea. Oh, it's not a bad idea. Is there some way to bisect argument passing? Yeah, I mean, that's not crazy either. God, there's just so many things. Can we... So... The assumption here that I would make is that these wrapped functions are somehow avoiding some shitty path that this thing is taking. But I'm trying to, I want to know where. Like, I want to know why this is happening, right? Who the fuck is, like, what the fuck is this? You know? Like, what is this? This seems like the type of thing that the idiot could ask us. What is this for? Fine. What is this for? We'll give him the whole fucking path. Okay, you're just making guesses the same way that I would fucking make guesses. Fuck you. Fuck you. Libg dot a no fp. Like, what is this thing? Ooh. Wait, is this? I'm surprised that there's simd in here at all. Ooh. Wait, okay, wait. Let's go to Cortex. Let's no FP plus no SIMD or something. Does not take any future options. Fuck you. Fuck you. But okay, so I suspect that that's related in some way, but I also don't really understand why this would be getting triggered at all. You're not allowed to stream this late. This is legal. Yeah, sorry. Ugh. I just don't know how to like bisect this effectively. Like, this seems fine to me. We could try like, what are we doing? We're trying to get as out of the way. Oh, get as far away from the Pico, the Raspberry Pi Pico SDK as we can. So we've managed to compile like a Blink example that effectively does not call into any standard library code. And now we're just trying to compile this thing. Can QEMU help or am I crazy? That's not an awful idea. I think that it'd be hard to get a QEMU setup that works correctly. But I think that would take too long. I think probably what I really want to do, like, if I just fucking had the debug probe on my desk right now, we could just open the debugger and see why it's failing, and that would be way easier to debug. So I think maybe we call it here and swing back when I have the debug probe, because it, like, we have the only like piece of information that we can get from this thing right now is the LED, and so when the LED doesn't turn on, we just have no info. Right? Like, what are we supposed to do? It's like something's not working, right? And so I think it makes sense. Ooh, you do have a link though. How does he compile? Because that's really the only piece we need. Bear blink pico. Is it gone? Make file near the end. You've got me. You've piqued my interest. Okay. Linker LD. So he has. Where is linker LD coming from? He probably copied it from the SDK. CRT0 he copied as well. So we're on the right path here, right? We're going to use their linker script with their CRT0. And he's got no standard lib is probably something that we want here. Yeah, let's try that. Undefined reference to exit. Okay. Okay, wait, okay. But we can just define exit ourselves. Right? Wait, hold on. Void, exit, void. Okay. That's promising. That's promising. Um, Pico. Nah, still nothing. Okay. Yeah, that was worth a shot. It's worth a shot. I think we're close. This feels like we're on the right path, but I really want to like see something instead of just like flying in through the dark. So we'll wait till we get the debug probe. We'll swing back, and then hopefully at that point we can start working on like I2C and stuff as well. Because I need to like solder the flash chip that I want to try programming and stuff. I need to solder it onto some pads. So next stream we should have the debug probe. I should have soldered that thing where it's supposed to go, and we can move on with trying to do some I2C stuff. But I think this was a productive stream. I feel like I understand this thing a lot better now. Right? I was worried that like the SDK would be like, I don't want to say like in my way. Obviously it's doing like the right thing, but I was worried that it would prevent me from understanding like what the hardware is doing. And I think we understand to some extent. Right? We got a little GPIO flash example by writing to the fucking GPIO pins, which I mean by knows what it's doing. We're really stretching that definition. We know that we can talk to some hardware through some hardware map registers. So, all right, cool. I think we called there. Thanks for watching, guys. If you like what you saw, we stream most days at 12:30 o'clock Pacific time to 4 o'clock Pacific time. It's 7:30 now because I wasn't really planning on streaming today, but then I wanted to do this, and it was like, we should stream this if I'm going to do it. So today's an odd day. We should be back tomorrow. Maybe I'll skip tomorrow. I don't know. We'll see. But most days, 12:30 to 4. If you want to keep up with like whatever projects we're working on, you don't catch us live. There's the YouTube link in the Twitch description where we post mostly like feature development for whatever projects we're working on. You shouldn't really miss too much if you watch what's on the YouTube. We do not post everything to the YouTube because some things I just like struggle to create titles and thumbnails for. And so in those cases, they go into the paywalled section. So you can join on YouTube or on Patreon or sub on Twitch, and you should get like the full VODs wherever it makes sense. Yeah, consider supporting, please. This stream will end someday because I'm losing money every day I'm doing this, right? And someday I'll need to get more money to eat food, right? But so at that point we'll stop streaming. But every dollar I gain before then is a delay to that happening, right? So if you want this content to continue, consider supporting. But if you can't, no worries at all. Otherwise, I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.